my name is Gana Miselos, and today we are going to learn how to convert binary numbers into decimal number. Computer use binary system. If the computer used the decimal system, there would be 10 possible states to a switch. This is time consuming and completely unnecessary. So to avoid hassle as calculations simpler, computer use the binary number system. Now, do you understand why computer use binary numbers instead of decimal numbers? Now that you know why computer use binary system, it is time for you to try now on converting binary into decimal numbers. So let's now converting binary to this. The method 1, which is the given is 92 base 10. So step in going to do this, we have to same as the decimal number we have taught on the elementary days. That's it. 2 to the power of 3, 2 to the power of 2, and 2 to the power of 1, which is 0. So we just add. So since the number is 92, we have to add of what number we have to use. So 64 plus 16 plus 8 plus 4 is equals to 92. So the answer would be, so in method 2 we are going to use the division system, which is a checking for the method 1. So 92 rather, this to the power of 10. So 92 by 2, we're just continuously divide by 2 until it becomes to 0. So 92 divided 2 equals to 46. So if there is a remainder, just put it 1. But if it's not, then put it 0. Then in this case, there is no remainder, then put it 0. 46 divided 2 is equals to 23, equals to 0, and remainder. 23 divided 2 is equals to 11.5. So since there is a remainder, we put 0. 11 divided 2 is equals to 5, and there is remainder again, we put it 1. So 5 divided 2 is equals to 2.5. So there is a remainder again, put 1. 2 divided 2 is equals to 1. So 0, there is no remainder. 1 divided 2 is equals to 0.5. So there is a remainder, we put it 1. So how to read that? Just upward reading. So 1, 0, 1, 1, 0, 0. We have the same answer of what we have in the method 1. So let's proceed to addition. In addition, there is a given rule. 1 plus 1 is equals to 0 carry 1. 1 plus 0 is equals to 1. 0 plus 1 is equals to 1. And 0 plus 0 is equals 0. So let's give it a try. Here is a given. 1, 0, 0 plus 1, 1. So 1 plus 1 equals to 0 carry 1. 1 plus 1 equals to 0 carry 1. And 0 plus 1 is equals to 1. 1 plus 0 equals 0. 0 carry 1. 1 plus 1 equals to 0 carry 1. And 0 plus 1 equals to 1. So the answer is 1, 1, 0, 1, 1. So to check, let's have, so let's put the binary number, get the decimal number. So that would be 11, 2, 4, 8, 15. So 11 plus 15 equals to 26. So possibly 11010 is equals to 1, 2, 4, 8, 16. So 16 plus 8 plus 2 is equals to 26, and we got the correct answer. So let's now proceed to multiplication as a part of a binary arithmetic. So in a multiplication, there is a given rule also. So 1 times 0 is equals to 0. 0 times 1 is equals to 0. 0 times 0 is equals to 0. And 1 times 1, of course, is equals to 1. So let's give it a try. Sample, sample, sample. The given would be 1, 1, 0 times 1. So 1 times 0 equals 0, 1 times 1 equals 1, 1 times 1 is equals to 1. So another example to be mastered. 1, 1, 0, 1 times 1, 1. So 1 times 1 equals to 1, 1 times 0 equals 0, 1 times 1 equals 1, 1 times 1 equals to 1. 1 times 1 equals to 1, 1 times 0 equals 0, 1 times 1 equals 1, 1 times 1. So let's add 1, 0 plus 1 to 1, so 1 plus 0 plus 1, 1 plus 0 carry 1, 1 plus 1 0, 0 carry 1. Sorry for the error. So let's now proceed to division. So let's give it a try. Here is the given. 101 divided by 1, 0, 1, 0, 0. Supposed to be that is 20 divided 5. So that's not enough. If 10, so with 1 0, so 1, 0, 1, 0, 0. So let's just simply carry that since there's no enough space. So 0, 0, 2, 0. That's it. So let's now proceed to subtraction. In subtraction, there are two methods, the first and second complement, but hence second complement is the best. We use also first complement and second complement, so we use the second complement. So there is a given rule also in subtraction, but we apply this. 1 minus 0 equals to 1, 0 is 1 equals to 0. 1 minus 1 equals to 0, and 0 minus 0, 0, 0, 1, 0 is equals to 0. So I'm sorry for the error. 1 minus 0 is 1 bonus 1. So try. We use the second complement. So the given would be 1, 0, 1, 1, 1 minus 1, 0, 1, 0, 1, 1. So in this case, we used to flip the denominator, which is the 0, 1, 0, 1. So we use the second complement as I said earlier. So we change 0 into 1. So in the denominator only. Okay. So instead of 0, we use it 1, 0, 1, 0, 0. So plus 1. That is the standard of second complement. 0, 1, 0, 1. So let's add this 1, 0, 1, 1, 1 plus 1, 0, 1, 0, 1. That would be 1 plus 1 equals to 0, carry 1. 1 plus 1 equals to 0, carry 1. 1 is equals 0, carry 1. 0 plus 1 equals to 1. 1 plus 0 equals 1. 1, 0, carry 1. So there is an overflowing here, so we just discard the 1. So that would be the final answer. Check. So now let's proceed to single precession. There is a sign bit here, which is 1 bit. the exponent is only 8 bits. The mantissa is 23 bits, and the bias, which is standard, is 127. So let's give a try. Let's give it a given here. Sample. Sample will be 1, 0, 0.11 base of 2. So let's change this into scientific notation. This would become 1.0011 times 2 to the power of how many times you are, so plus 127, so that would become 129. So the exponent with that, just like the binary number, it would become 0 plus 1 0 0 0 0 0 1. So that is the exponent. So since let's remove 1 point and x2. So since this is an unsigned bit, this becomes 0, and the exponent and the mantissa 0011. Since we have 23 bits, let's put 19 zeros. 0s. So that's the answer. Now let's proceed to double precision. Just like the single precision, there is also a sign bit, exponent, the mantissa, but they have different numbers. So sign bit would be 1, same as the single. The exponent would be different now as what the single would be. So it beats 11, I mean. If the single precision is 8 bits, then the exponent would be 11 of the double precision. Then mantissa would be 52. In the single precision, that is 53. So 52 in the double precision would be 1023. So try. Same number as what we did in the single precision. So given would be 1. So quick notation, same as what we did in the single precision. 1, that will become 1.011 times 2. So 2 moves plus 1023. That would become 1025. So let's convert it into binary number. That would become 9 zeros and 1. Do you know the procedure that already? So since this is also an unassigned bit, so positive, this would be positive. So 0, then put the exponent 2, 3, 4, 0, 1. Then the mantissa 0, 0, 1, 1. Since the mantissa here is 52 bits, then 4 minus 52 bits will become 48 zeros. That's all. Then we have